Welcome to Easy BTech, your guide for BTech and beyond. Okay students, today's the topic is transistor biasing. We will discuss the importance of biasing circuits. Okay, in the previous sessions we have clearly studied about what is a fixed bias and what are the fixed bias stability factor, because for a fixed bias network, for a fixed bias circuit, the stability factor is 1 plus beta. Now the value of stability factor is very large, then the such type of system is said to be unstable. Okay, the stability factor for the fixed bias is unstable because of a larger value of beta, and such type of circuits are not widely used. Now we will use the second type of concept, second types of biasing network, that is a collector to base bias circuit. Collector to base bias circuit. Collector to base bias circuit. In this collector to base bias circuit, you can see the structure clearly. Okay students, this is the collector to base bias circuit. Now you can clearly see here, this is the collector to base bias circuit or a feedback bias. It means the base resistor is feedback to the collector, the base input is feedback to the output terminal with a feedback resistor, or a feedback resistor bias or base feedback bias we will call in this manner, because the connection between the input terminal is the base and the output terminal is collector. A feedback resistor is connected to input to output, that resistance is an RB. Okay. Now this is a circuit for an previous case we have studied, that is the reactance of the capacitor for an DC supply is, because for a DC frequency is 0, the reactance is 1 by 0 infinity. Infinity reactance means it is an open circuit. Okay, for an DC analysis, this capacitor can act as an open circuit, and the revised circuit we may draw in this manner, that is for an DC analysis we will draw the circuit like DC analysis. This is VCC. This is VBE, here the voltage, and here to here the voltage is VCE, and it is base, it is collector, it is emitter. This resistor is RB. Now here the current is I, this current is divided across here, this side current is IB current and this side current is IC current. Okay students, we will write the loop equation by applying the KVL. it is a loop 1, it is loop 2, loop 1 and loop 2. Loop 1 we will write VCC is equal to I into RC plus this side IB RB plus base to emitter VBE. Okay, we know that, therefore the total current, this side current, here the current division you can clearly understand, this side is IB and this side is IC. The total current is I is equal to IB plus IC, I is equal to IB plus IC. We will write VCC is equal to, that is IB plus IC into RC plus IB RB plus VBE. Okay students, from this we will write VCC is equal to IB RC plus IC RC plus IB RB plus VBE. Okay, you can understand this. I hope you understood this, students, very clear by applying the KVL across loop 1. You will write VCC is equal to, the IB term you can make the common, IB RB plus RC, here RB, here RC, plus IC RC plus VBE. Now you can make this term this side, VCC minus VBE is equal to IB into RB plus RC plus IC RC. And to find out the value of IB, this term is also you can bring this side, that is you will get VCC minus VBE minus ICRC is equal to IB into RB plus RC. Okay, to find out the value of IB is equal to VCC minus VBE minus ICRC by, you will write as RB plus RC, RB plus RC. This is the value of IB, base current, from the loop 1 equation. From the loop 1 equation, by applying the KVL across the loop 1, we will get the base current in the input side. And in the output side equation, we will write in the output side equation VCC is equal to I into RC, I into RC, I into RC plus I into RC plus VCE, VCE. Now you can write this VCC is equal to, I means we already know that IB plus IC into RC plus VCE. Okay, this we will write VCC is equal to IBRC plus ICRC plus VCE, the second equation. Already from the first equation we can obtain that IB is equal to VCC, that is in the previous you can say this is the value, VCC minus VBE minus ICRC by RB plus RC. This we will write in this manner, VCC minus VBE by RB plus RC for an easy understanding, and minus ICRC plus by RB plus RC. This is the equation. This is an IB current. Now differentiate IB to find out the stability factor. What is the stability factor equation? 1 plus beta by 1 minus beta, differentiation with IB by differentiate with respect to I. Differentiate IB with respect to IC. Differentiate IB with respect to IC. Now this is an IB equation. If you differentiate this equation, differentiate IB with a differentiate IC. Now here you cannot find any other term. Okay, in this term you cannot find, it is a constant. Okay, derivative of a constant is 0, 0, minus. Here IC is there, you are differentiating with respect to the IC, means 1, IC by IC 1, let minus RC by RB plus RC. Okay, in place of dou IB by dou IC, in this place you can write minus RC by RB plus RC. You can substitute in the stability factor. Okay, okay students, what you will get? Stability factor is equal to 1 plus beta by 1 minus beta into minus RC by RB plus RC. Now what you can find? 1 plus beta by 1 plus beta into RC by RB plus RC. Now what you can find? Now for a fixed bias circuit, the stability factor is more. As the stability factor is more, then that circuit is unstable, whereas in this case what you can find as RC, this is the value, as RC increases, that is you can say if temperature increases, IC naught increases. As IC naught increases, IC increases. IC increases, RC increases. RC increases, then definitely RC increases. Now it is a stability factor is inversely proportional. Stability factor is inversely proportional. That is, if RC increases, the stability factor will decrease. Okay. Remember, as that if temperature increases, IC not increase, IC increase, RC increase, but the stability factor increases, stability factor decreases, because stability factor is inversely proportional to the RC. Stability factor is inversely proportional to the RC. This is one of the best compensation method. Now the stability factor can be minimized now for a better stability purpose. For better stability purpose, we use this base to collector or collector to base feedback resistor biasing is used. For better stability purpose, we use this base to collector feedback resistor is used. Okay. Now you can clearly see here, initially what you can obtain from here, initially you can clearly study here, as an IC gate increases, as the temperature increases, reverse saturation current increases, IC increases, RC increases, but the stability factor will decrease because of the inversely proportional to the stability factor to the collector resistance. Okay. This technique of IC, okay, this technique of IC is used for a better stability purpose, for a better stability. As the stability decreases, then automatically this circuit will become more stable. This circuit may become more stable, and stability or stabilization can be exist. As the system becomes a stabilization, as the circuit becomes stabilization, then it will be used as a distortion free output or a faithful free output or faithful output. Okay students, this is the stability factor for the base to collector bias network. Okay. By taking a small example, we will find a small problem, we will find these equations now. Okay, students. In a biasing circuit, with a feedback resistor, a silicon transistor is used. The operating point is at 7 volts 1 milliampere. Operating point is used at 7 volts 1 milliampere. VCC is equal to 12 volts. Assume beta is 100. Determine the value of RB. Next, second one is stability factor. This has been asked the question. Okay, students, you can clearly understand here. It is a given problem. What in the problem? It is a feedback resistor, means a collector to base bias circuit is used. He has given in the problem beta given, beta is 100, very good, and the operating point, that is IC has given at 1 milliampere, and VC has given at how much? 7 volts. This is the given problem, and he has given VCC is equal to 12 volts. This is clearly mentioned. Now, from this, to find out the value, okay, to find out the value of stability factor formula is 1 plus beta by 1 plus beta RC by RB plus RC. Okay, this is the stability factor. Now, to find out that, first we need RC and we need the value of RB. Okay, this is the condition. To find out the value of RC, okay, what is the equation? How we can find? That is VCC is equal to ICRC plus VCE. From this, to get the value of this VCC is equal to to get the value of RC, VCC minus VCE by IC, we will get the value of RC. Clear? From this, to find out the RC. Now, RC is equal to, given the value 12 volts minus VCE 7 volts by IC. IC how much he has given? 1 milliampere. Now, 12 minus 7, you will get 5 kilo ohm. Okay. From this, you can clearly study this is the value of RC value. RC value is obtained from this expression. RC value is obtained from these expressions. Okay, students. Similarly, we will find the value, that is RC known and IC known. Okay. Now, from this, you will find IC is equal to beta IB. Okay. From this, to find out the value of beta, to find out the value of IB, we will write IC by beta. What is the value of IC? 1 milliampere. 1 into 10 power minus 3 by beta. Beta value is given 100. Okay. Then it will goes up, what you can get? 10 power minus 5. 10 power 2 will go up 10 power minus 5. 10 power minus 5 means, you may convert this into 10 into 10 power minus 6. 1 will go, you will get 10 power. It means we can write as a 10 microamperes. Okay, the value of the value of IB, base current is how much? 10 microamperes. Always you can remember, the magnitude of the collector current and the emitter current is in an order of milliamperes. and the magnitude of the base current is in an order of microamperes, because the base is lightly doped and the width of the base is very narrow and the base current is also very less, and the base current is also known as recombination current. The another name of the base current is recombination current. This recombination current is used for an excellent transistor action. Okay students, now from here we have found the value of RC and we have found the value of IB. Okay, these two parameters are used for the calculations of the RB value. Okay, the value of RC and the value of IB, these two values are sufficient to find out the value of RB equations. Okay, now what is the equation of an RB, how we can obtain that? Okay, you can clearly study here. That is VCC is equal to ICRC plus IBRB plus VCE, that is we will write as an VBE, this input side equation. Okay, I will show this equation. In the previously we have written that. Okay, these are the equations. These equations we will write from this. VCC is equal to, from this, to find out the value of RB, we can clearly write in this manner, that is VCC is equal to IBRB plus RC, ICRC plus VBE. Okay. Now from this we will find that value, that is VCC is equal to ICRC plus IBRB plus VBE. Now from this we will find the value of RB, that is VCC minus VBE minus ICRC by RB by IC, we will find the value of RB. Okay. Now VCC, what is the value of VCC? 12 volts minus VBE 0.7 minus IC 10 in how much you are getting the IC value in the previous? IC value we got IC given 1 milliampere. Okay, 1 milliampere means 10 power minus 3 into 1. RC value how much? 5 into 10 power 3 by IB value how much? 10 into 10 power minus 6 is equal to RB. Now we will get the value of RB is equal to 12 minus 0.7 minus, now what you will get, 10 power minus 3, 10 power plus 3 will goes, it will be 5 by 10 power minus 5, isn't it? Okay. Now from this you will write 12, this is 12 minus 5.7 by 10 power minus 5. 12 minus 5.7 you will get like a 6.3 into 10 power minus 5. Now if you obtain this, you will get this 10 power minus 3, it will goes up, you will get 10 power 5, it will go 10 power plus 5, then you will get the value RB is how much you are going to get? 63 into 10 power 5. Okay. Now if you write 6.3 into 10.5, if you remove the 2, this one multiple 63 10 power 4 another is into 10 power 3, that is you will get a 630 kilo ohm. See here 63.3 into 10 you will get a 63 10 power 4 another 10 by the calculation of decimal digits, you will get the value, that is the value of RB is 630 kilo ohm, and the value of what you are obtained, you got the value of IB at 10 microamperes, and you got the value of RC value is RC how much you got, 5 kilo ohm, and RB value you got at 630 kilo ohm. This is the value you got it. Now by taking this into consideration, we will find out the stability factor. Now what is the stability factor equation? Stability factor is equal to 1 plus beta by 1 minus beta 1 plus beta RC by RB plus RC. Now what is the stability factor? 1 plus beta, 1 plus 100 by 1 plus 100 into 5 kilo, 5 into 10 power 3 by, now here RB RC, now it is one is 630, another one is 5, that is 635 into 10 power 3, 10 power 3, 10 power 3 will get cancelled, then you will get 101 by 1 plus, you will get 500 divided by 635, 500 divided by 635. Now by taking this value and by taking in this consideration, you will get the value like 56.5, 56.5, the stability factor for self bias. Okay, sorry, the stability factor for base collector bias, base collector bias is 56.5. Suppose the stability factor for fixed bias, then it is how much? Then it is 1 plus beta, that is 101. Now you can say the stability is reduced, means a better output you can get, a distortion free output you can get from this network. Okay students. Okay students, easy BTech, guide for BTech and beyond. I hope you understood this base collector biasing. Okay. Now as the temperature increases, IC naught increases, IC increases, RC increases, but the stability factor is decreased. Now for the same value of beta you can obtain it here, how the stability factor is reduced. Okay. Now this base collector bias or feedback, base to collector feedback resistor bias is more stable compared to the fixed bias circuit. Okay students, thank you.